Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good day everyone. And welcome to today's See Think Webcast series number 4. Before we get started, I'd like to go over a few items so that you know on how to participate in today's program. So See Think Webcast is brought to you by UMP STEM Lab in collaboration with the Ministry of Education, National STEM Center, Pusat STEM Negara and Pusat Islam dan Pembangunan Insan Pimpin UMP. On the left-hand side of the poster is a QR code and the link to the attendance registration. You may ask questions during the presentation. We will collect these questions and address them during the question and answer session at the end of today's presentation. You will have the opportunity to submit text questions to today's presenter via typing in the questions in the comment section via YouTube or Facebook. Okay, before we get started, let me introduce you to UMP STEM Lab. So basically, UMP STEM Lab was established back in 2016 with the ultimate aim to introduce the community with the digital making skill set curriculum, covering from three-dimensional design, programming, manufacturing, as well as physical computing. Throughout the years, we have engaged with various parties, government and non-government organization, agencies, to bring in and to do engagement and to engage with school children as well as teachers Among of our signature programs are Hackathon, as well as My STEM Ambassador, and also the upcoming program in which we will be collaborating with UNESCO. So See Think Webcast is another program that is brought to you by UMP STEM Lab with the ultimate aim to discuss on trending topics and issues that are related to science, technology, engineering, and mathematics. It is also our aim to feature role models as today's presenter to share their exciting journey taking the STEM career pathway. So today, I would like to welcome Dr. Ikhwan, Technologist in Senior Dr. Ikhwan, Muhammad Ikhwan bin Muhammad RIdzuan, as our presenter for series number 4. So Dr. Ikhwan went to Sekolah Menengah Teknik Gombak and later did his Bachelor of Engineering in the University Technology Malaysia. He soon continued his PhD in the University of Edinburgh and obtained his PhD in 2017. Before becoming a senior lecturer in University Malaysia Pahang, Senior Dr. Muhammad Ikhwan was an electrical engineer in Tenaga Nasional Berhad. So without further ado, let us welcome TS Technologist in Senior Dr. Muhammad Ikhwan bin Muhammad RIdzuan as our presenter for today. Dr. Ikhwan, are you ready? Unmute your mic, Dr. Ikhwan.
Does this presentation must be in full English or can be
Can be a mixture. Can be mixture bahasa Melayu.
Okay. Okay, thank you, Professor Madya, Engineer Dr. Nurul Hazlina for introduce me. Okay. This is quite a bit. I mean, this is first time for me to present to all audience about the smart grid. Okay. Okay, this is the picture of me. I'm graduate from the University of Edinburgh. Okay.
Dr. Ikhwan, tengah share slide dah.
Dah ada slide kan?
Okay. Dia tak appear. Okay, sekarang ada. Okay, Dr. Ikhwan.
Okay, sorry. Okay, this is picture of me. Okay, sorry. Sekejap dia kenapa dia macam okay, ini ialah semasa saya this is me doing my job in Tenaga Nasional Berhad. Okay, you can see at the first picture, this is training. I mean to measure the insulation of the insulator. Okay, and if you look at here, this is me. It's not really that I'm piloting the helicopter. It's just that I mean doing the working. I was at the back. I mean looking at the transmission tower whether it's okay or not. Okay, and if you look at the fourth picture, it's me. I mean beside the transformer. Okay, before we go into smart grids, first we need to first I need to declare something. Okay, this presentation is I designed for secondary school and pre-university student. So the term used is not very technical, or if there will be certain technical word, but I will explain to you. Okay, first we look at something that use the word smart. Okay, kalau kita tengok sini, if you look, there are two types of phones, which is traditional phone and smartphone. Okay, between these two, how does the smartphone become smart? Is it is it because of intelligence? Is it because it can call? I mean, we just click our hand and then the phone will call by itself. So we take a look at the simple example of a phone before we go into smart grid. So we look at the function. Okay, the previous phones, I mean the traditional phone are usually for texting and calling only. Okay, for smartphone, they have put many features such as emails, internet access, gaming apps. So if you look at this term, the phone becomes smart because it put a lot of features, not because it is smart. It can work by itself. If you look at a smartphone, the only thing that becomes smart, they put a lot of things into a phone. Okay, then we look at the camera. For the camera, we have so many. For the previous, I mean, for the traditional, then you have some may have, some don't have a camera. But the new camera, the new smartphone, they have many features of camera. And then we go and look at the purpose. Okay, and then there's, of course, smartphones always offer a lot of things. It's offer on the go convenience. It means that you can check your email, you can check your slides, you can check your notes on the emails rather than open in laptop. Okay, and then of course, lastly, the function, the factor that we look at the phones is the traditional phone, of course, this is cheaper because less application, and smartphone is expensive. As I said before, the smartphone only becomes smarter because they put a lot of apps, they put a lot of things in the phones, but not with smart grid. We don't put everything and then just leave it. We need to do something, whether so that the grid can working automatically by itself. And for example, if there a fault, the supply can transfer it to another load. Okay. What is really smart grid? Smart grid. Okay, grid that we know is something that transmission line, which is covers from generation to transmission. And then smart is something not we put thing in the grid. It's just that it can function automatically. Okay. If you look at here, smart grid contains green energy. For example, in Malaysia, we are working towards solar energy. And then we also are moving towards, electrical vehicles. Even though that electric vehicle is quite expensive right now, but there are certain people possible to buy this electrical vehicle. And then for the conventional power plant, they are trying to reduce the operation of this, such example as coal power plant, gas power plant, because they emit a lot of CO2 emission. Okay, before we want to know what is really a smart grid, first we need to understand what is in the power system. Okay, In the power system, basically there are three type of component. The first one is generation. Second one is transmission, or we can call it grid. And the third one is distribution. Okay, and for us, for the most of us, it actually belongs in this part, distribution and consumption. For the consumer like us, we are always in distribution and consumption. Okay. If you look at this diagram, the bulk generation, which is, for example, gas power plant, coal power plant, they are located further from the customer. Okay, because they are quite big, and they're quite dangerous. Okay, for certain country, they are using nuclear power plant. Okay, for transmission, okay, we can see it at beside the roads, there are many transmission lines, and this transmission line is quite long. Since the transmission is long, so it has higher losses in kilowatts. So this losses is considered as a waste because we are not using it, but we are not using the electrical, but the current is still in the transmission line and cause losses. Okay, so now we look at the generation. These are the picture example of different type of generation. In Malaysia we have hydro, and we have gas and coal power plant. Okay, there are many type of power plant, hydro, wind, solar. Tidal we don't have any. But the main thing is that these power plants are designed to provide electricity. Okay? So it doesn't. So if you look at our home, if you look at our apparatus, we doesn't know our electricity is come from where. So in the future, it is better that most of the power plant is come from the renewable energy. I will explain later why we need more. Why Malaysia is now targeting renewable energy. Cool. So these are the example of fossil fuel. So it can either be gas, oil, and coal. So the main thing, if you look in the steam turbine, it always boils the water. Okay, for this fossil fuel, the fuel is used to boil the steam. To boil the water, and then the water becomes steam, and then the water will be pressurized. Will become high speed pressure, and then that pressure will be channeled to the turbine in order to spin the generator. So this concept of spinning the turbine will change the kinetic energy to electrical energy. Same also apply to the nuclear. The fuel itself to heat the water and become pressure steam. But it is different for okay. These are okay. The first point of the generation is the conventional power plant, which is coal fuel to convert electrical energy, and then the power generated is typically within this voltage, 11 to 25 kV. And then the main component of generator and transformer are in the generation. The transformer itself is to step up the voltage. For example, from 11 kV to 132 kV. From itself, sorry, to step up from 11 kV, for example, to 132 kV or 275 kV. Okay, these are the currently what are the main fuel in Malaysia. If you look in this diagram, the base part of our generator is from the natural gas. So we can see most of the generation is come from the natural gas, and certain from the larger portion from the coal. So these two type of fuels will emit CO2 emission, which is not good for our environment. So what about hydro? Hydro is something that we use lesser. Even though we have hydro, but I mean, it is possible to open. It is possible. I mean, the hydro is to contain the water in the dam. Okay, so it is impossible to open the dam 24 hours. So if for example we open it for 24 hours, or let's say for a week, the whole dam probably will become depleted. So the only thing that we can use to save money by using and to reserve some energy in terms of water, we use hydro as a peak load. The hydro as peak load. Okay, and then these two, let's say natural gas as a base load. Okay, now we look. These are the if you look at the wet part is powered by gas. These are the location of generator in Malaysia. Does anyone know why, if you look at this generator, why all of this type of generator is located at, near to the sea? Why this generator located near to sea? Sorry. This is just job scope. Okay, sorry. Okay, the reason why this type of generator is located near to the sea, because of they need cooling system. Okay, we know that as a previous slide, this coal and gas burns. Burn water, become steam. To become steam. So this plant is hotter. This plant is extremely hot. So it requires seawaters because it's free to as a cooling process for the power plant. So this is the reason why we see that most of the power plant is located near to the sea. Certain less, if you see this one is the blue point is hydro. So this one is located based on the location of kawasan yang dekat dengan tasik. Dr. Hazlina, kita nak kena jawab ke soalan ni? Boleh jawab soalan sekarang ke? Hello? Okay. Ada satu soalan. Okay. Ada satu soalan dia. Ada soalan ni. Macam mana saya nak deserve job untuk macam nak jenis job lah. Macam mana saya dapat job ni lah untuk course smart grid ni. Okay, smart grid ni dia berkaitan dengan kebanyakannya dia berkaitan dengan electrical. And of course lah, kalau dah berkaitan dengan electrical mestilah kena ambil bidang yang berkaitan dengan electrical. Jadi kalau boleh sambunglah bidang engineering dalam bidang electrical. Okay, boleh menjawab ke? Okay, soalan nombor 2. Okay, soalan nombor 2 ni, okay, saya ada beberapa soalan ni. Ada soalan nombor 2. Adakah elektrik dan elektronik ni benda yang sama? Jawapan dia, elektrik dan elektronik ni dia adik-beradik tapi dia tak sama. Okay, macam contoh elektronik dia punya voltage dia selalunya kecil. So, contoh macam 5 volt, 12 volt, voltage dia kecil. Lagi satu dia lebih kepada komponen macam komponen elektrik yang kita tengok macam telefon, komputer. Okay, kalau elektrikal ni dia benda yang besar. Dia macam transformer, motor, lepas tu engine kereta. Walaupun dia ada part mechanical sikit tapi dia ada juga bahagian electrical. Dia nak conversion daripada fuel ke kinetic energy. Okey. Soalan nombor 3. Okey, kenapa kita perlukan 3 phase? Bukan 1 phase. Okey. Kenapa kita perlu 3 phase Okey, sebab kalau 1 phase tak cukup nak bagi power. Sebab 1 phase dia contoh macam kabel. Sorry. Contoh kat sini Macam kabel tu dia ada dia punya size dia. Dia ada size dia dalam ampere lah. Ampere. Dalam arus lah. Okey. Jadi selalunya kalau macam rumah yang contoh macam kita tengok contoh macam ada setengah rumah dia guna single phase, ada yang guna 3 phase. Okey, semua tu bergantung pada load dekat rumah tu. Kalau macam dalam rumah tu banyak guna aircon, banyak guna mungkin ada banyak tempat masak ke kan, mungkin ada tempat masak elektrik, ada electrical apparatus yang banyak lah. Contoh macam dia banyak guna iron kan, banyak guna air, banyak guna aircon. Kalau aircon pun dia tengok juga, dia kena kira lah. Dia tak boleh macam saya kalau rumah saya 1 aircon, saya nak pasang 3 phase. Boleh juga, bukan tak boleh, tapi dia tak berbaloi lah, dia tak optimum. Selalunya digalakkan macam kalau rumah tu pasang lebih 5 aircon kan, dan aircon tu selalunya di on pada waktu yang sama. Okey, dia lain di on waktu pada yang sama dan di on pada waktu yang berbeza tu lain. Kalau 5 aircon tu, contoh 5 ke 10 aircon di on pada waktu yang sama. Okey, yalah kita tengok jugalah, dia tengok juga kepada berapa jenis horsepower aircon tu. Kalau aircon tu di on pada masa yang sama, seeloknya ditukar kepada 3 phase sebab rumah itu memerlukan arus yang tinggi. Sebab tu perlu banyak 3 phase. Bila ada 3 phase, dia bolehlah bawa banyak current. Nampak ni, ada current 1, ada current 2, ada current 3. Okey. Okey. Tadi kita tengok konvensional punya sistem generation yang mana di kebanyakannya Yang kebanyakan ni diguna apa? Fuel untuk panaskan air untuk jadi steam. Tapi berbeza dengan wind. Wind ni dia terus direct pusing turbine ni. Wind ni daripada arah sini dia terus pusing turbine. Dan kat sini ada generator lah. Generator terus tukar kepada elektrik. Dia lebih straightforward lah. Dia tak ada macam dia ada juga sikit loss, tapi dia tak macam loss dia tak banyak lah macam dekat tadi tu. Dia punya conversion nampak ni, boleh nampak kat sini dia asal daripada wind power, dia tukar kepada mechanical, dapat kepada electrical. Okay, dia lebih direct lah berbanding dengan conventional. Okay, kalau solar panel sama juga, dia direct. Matahari yang tegak sini terus pancar. Okay, dia sebenarnya dia kalau ikutkan, kalau nak ikutkan lebih dalam, dia sebenarnya dia ada pergerakan elektron dalam ni. Elektron tu, tapi tu kos lain lah. Okay, dia akan convert electrical jadi elektrik. Lepas tu, inilah charge controller ni bertujuan kita nak apa? Kita nak stabilkan voltage tu. Ada banyak lagi tujuan lain, tapi selalu tujuan ni kita nak stabilkan voltage tu. Dan di sini inverter ni, kalau kita tengok solar panel kalau tadi pun, kalau untuk ni pun, kalau untuk wind pun dia bergantung juga. Dia ada yang DC, dia ada yang AC. Tapi nanti tu kos lain, kalau ada rezeki lah, kalau ada kos lain boleh ceritalah perbezaan DC AC. Okay, kalau tengok sini solar panel kebanyakannya dia ditukar, dia output dia dalam bentuk DC, direct current. Direct current ni contoh macam kita punya bateri lah. Macam kita punya bateri kan straight je kan, straight je kita punya apa waveform tu. Tapi kalau untuk jadi bila nak tukar kepada AC, alternating current, nak tukar dalam bentuk macam ni, dia perlukan inverter. Inverter ni lah yang akan menukarkan daripada DC ke AC. Jadi inilah contoh penggunaan mana kita akan pasang, kebanyakannya mana yang berminat boleh pasang solar panel di rumah. Sekejap bahasa Melayu, sekejap bahasa Inggeris. Okay, transmission grid. These are the example of transmission grid in Malaysia. You will see this. You can see this everywhere. This type is called lattice tower, and this is called monopole tower. Mainly this monopole tower can see. You can find at urban, for example in KL and Selangor. Okay, transmission also not only for overhead line, but is also in underground. You can find it for underground cable. There are certain for this. Okay, the function of transmission, as we see at the very beginning, I have shown you that transmission line is very long. Sorry, the transmission line is quite long. So the function of transmission is only to transfer energy from generation to distribution. Okay, these are the only function of transmission. And then connecting between two substation or between two generators, between more generators. Okay, in Malaysia, the operating voltage is 132 kV and 500 kV. This voltage in three phase. Okay, this is not just this estimation is just about the conventional existing or of our system only. We still not touch about smart grid yet. Okay, so these are the actually there are a lot of interconnecting parts between generator, between this and this, between this and this, this and this. There are a lot of interconnecting, but if I want to present here, it requires a bigger picture. It requires a big file to present to you. So this generator, this type of generator is connected by transmission line. So for example, if anything happen to this part, this blackout, certain part can cover. Let's say this substation or this power plant can cover the load at this part. Okay, these are the aerial view of substation. There are many equipment here, and for this course, we're not touching the parts of the substation layout. There are many parts in the substation. You can find there are transformers, there are circuit breakers. Okay, but for these courses, we're not touching. We will not go into this type of component. Okay, distribution. Okay, for distribution system, this one is quite near to our home, because most can find it everywhere. We can find this transformer, and then we can see this conductor even in front of our house. So the distribution part, as the function of distribution part is, as it's called by its name, is to distribute energy to customer. Okay, the voltage for distribution are different. They are 33. These are in 3-phase. 22 kV is also in 3-phase. 11 kV is also in 3-phase. 400 kV is also in 3-phase. Just 220 kV is in single phase. Okay, so these are the example of from the picture figure of from generator transmission and to the customer. Okay, now we will look at this. We will comment about we will take a look at the attributes of the conventional power system. Okay, if you look at this power system is actually designed in one way flow. It never in two ways. The conventional power system or the existing power system is designed in one flow, and then we can see that the generation are mainly gas and coal, and of course is centralized, is located at remote area, and then we can see that the attributes is cause CO2 emission, and then so if you could demand, this is something that we will touch, because demand is something that we need to control. Utility need to control the usage of electricity of the customer. So at the moment that the traditional or the existing power system, utility will not control the usage of customer. And then we can look, the automation is limited. It require certain manual human touch to repair, to rectify the problem, and then lack some data to manage. Okay. Okay, we can see, okay. Now, okay, the only thing that we need to stress is it is in one power flow, centralized, and cost CO2, and in control demand. Okay, now we go into the smart grid. Okay, these are a picture of smart grid. If you look at the picture now, all the distribution part become in center. Look here, all the distribution part become in center. If you look at the transmission and the generation, just stay at the side. Okay. Okay, so now we look at the definition of smart grid. Okay, of course, everyone need an efficient electricity, reliable and secure electricity. No one want to have, no one in this world or in the part of the country want at least blackout in their house. No one want no one need blackout in their house. Okay. The customer always assume TNB, in Malaysia, TNB must supply electricity 24 hours. I don't care whether you okay or not, but I need efficient, reliable and secure electricity. So, another term for the smart grid is electricity grid brain, and then called internet energy. Okay, the more comprehensive smart grid mean that it has bidirectional energy flow and two-way communication and control capabilities. Okay, we look at the previous slide. See, the existing and traditional power system is one way. Okay, and then the utility doesn't have any information about the usage of the customer. Utility doesn't have any information here. Does it have lack data of on the customer side? So smart grids, of course, it needs some kind of communication. Let's say, for example, internet, but not open source internet, not open internet. Must be a secure internet, secure communication. Okay, now everything, if you look here, everything is in control. For smart grid, the utility will know the usage of your home, know what type of energy is transferred. It can collect data on the solar and wind turbine, and then this is about the storage. What the future technology is about the energy storage. How much energy can be stored in the storage? In the battery. Everything will come into together with the communication. And if you look in certain part of the world, they have this called smart building. Okay, smart building is something that it will turn, it have a good automation. For example, if there is no one in the building, for example, in that floor, in that area, the light and the aircon will turn off by itself. But there are also certain factors, certain attributes to the smart buildings. If you look in the future, there in a certain part of the world, they have installed solar panel at the window. They install solar panel to the window. That means the building itself will generate electricity and sell to utility. Okay, these are the concept of smart grids. Each part of the system will communicate. Okay, they have so many communication, with storage, with microgrid. Okay, so these are the certain attributes of the smart grids. Must be information based. That means customer, for example, you want to know right now what is the load of your house. You want to know the load of your house, and then you want to know what is the bill at the moment for your house. So must be information based. So there must be a two-way communication between customer house and utility. They have installed this certain part of meter which is called smart meter. So this smart meter will communicate with utility. And then the third attributes of smart grid must be secure. That if there any fault certain part of area, I still can get electricity. For self-healing, it's the same definition, reliable. And if you look at the certain, this one is, we will also discuss about this cost effective of the attribute of smart grids. Because in our country, Malaysia if you look at the previous slide, the load profile of our fuel is mostly come from gas and coal. So this raw energy typically Malaysia need to buy, TNB need to buy. So this is quite expensive. So Malaysia is targeting towards renewable energy, because this is the raw, wind is free. Sun, which is solar panel, is also free. Okay. So Malaysia are now moving towards renewable energy. We also discuss, after this we also discuss about renewable energy. And then the element control, we can control which part of demand we want. This is about controlling the load. This is also we discuss in the next slide. Okay, these are this figure is an example of smart grid. Okay, so if you look at the first attributes, the first thing that they are focused is about demand management. That means utility in Malaysia, let's say for example TNB, want to control your usage. TNB want to control your usage of electricity. then it become question to us. Why TMB want to control our usage? For example, want to control our computer, we use a computer, fan, or aircon. There must be a reason why TMB want. It's not just TMB. Other parts of the world also try moving in try moving towards this control demand. Okay, the reason is because of the load factor. Okay, so as I said before, this will not be too technical, but there must be certain part that I need to explain. Okay, load factor is average load divided by peak load. That means I want to know what is the variation of your peak between peak and average load. Okay, for example, let's say these are the, let's say this is 0 hours, this is 24 hours. 24 hours. Okay, at night, at home, we usually use electric at night because most of the time we will be at the office. Okay, so this time we'll be at the office, we will not be at home. So the usage of electric at home will be minimum at our home. So the large portion of our usage at home is at night or at the morning. So as you can see here, there are a variation of load profile here. This is the kilowatt hours. This is time. So we will use electricity mostly at night and morning. So TMB want to control our at least become constant. They want us to become constant like this. It's better to them. It's better to MB for us to have a constant load for all day, all time. Okay. This is what they want. They want to cut our usage. Sorry. They want to cut our usage here and transfer some here. Transfer of this peak load. They want us to TMB prefer. It's not they're not the one. They prefer us to transfer all this load into this time. Okay. So for certain people, it's not. We don't want to change our daily usage because we are getting used. Turn on the aircon at night. Open TV between 6 to 8. Okay, we are normalized to that behavior. So TMB suggests us to change the usage of electricity. For example, can you change, for example, turn on the aircon only at let's say for 2 hours or 1 hour only? Or for example, can you wash your clothes at night? Okay. So if TMB want to ask, if TMB want to ask us to change the behavior, there must be some incentive from TMB or some from the government. Okay, sorry. Okay, I will explain what the incentive. But we look at the why we need high load factor rather than low load factor. Okay, let's say we have a large variation of load. See here, large variation of load. So the cable size must be at this point. TMB must buy a cable size at this size. Let's say price A, the size of A, which is bigger. So they must buy equipment which is at bigger size. Okay. Of course, when the size is bigger, when you have so many components in larger size, the cost will become expensive. Okay. And then if you look at the usage, the only time that the cable is used at its best, at the maximum, is at this point only, which is rarely used. Okay. If you look at the ROI, this is different type of parts. This is not good. Okay. So if you have a better high load factor at the constant load, let's say even though there's a variation, but the fluctuation is not big. Okay. And then TMB can just buy this kind of cable size, let's say size B. Okay. So smaller size, some with cheaper cost, and then this thing is, the component is fully utilized. So between these two, low factor and high load factor, if I am a businessman, I prefer this one because this is cheap and fully utilized. Okay. For our part, which is customer, of course we don't care about it. But for the utility or government, when they want to spend money, okay, which is again our money, which is from the government, they try to maximize the cost. I mean, not maximize the cost, maximize the usage and minimize the cost. So that's why these are why TMB, I mean not TMB, suggests us to control our load. I mean transfer for some of our load, which is in here, which is peak, to some part of this area, so that they can only buy this type of cable size. For example, they can buy this cable size rather than they buy this cable size. Okay, advanced metering. So these are the communication which is in the between our home and utility. It can provide bi-directional control. I mean, you can also know the price at the time. You can know also the load at your home in detail. Okay, now we go towards smart appliance. Okay, we can see nowadays there are many types which is can be controlled by our phone. I mean, if you want to turn off the light, just by clap your hand, or by pushing a button at your phone, pushing your phone. Okay, push a button, certain part of your button in the phone. You can turn on, turn off TV by in the smart home. So since all of this part is connected, okay, and then this part is also connect to the previous, which is smart meter, advanced metering. So TMB now, okay, this is so this is to TMB. TMB now will know what is the type of load in your house, what is the usage of your load in your house, they know how many hours you turn on the aircon, how many hours you turn on the light, okay, how many hours you wash your clothes, okay, how many hours you turn on the TV. In the future, this utility will know your usage. Okay. Okay, again, in the future, it is target that most of the vehicle will change from conventional to electrical vehicle. Okay, but why we need to change from electrical vehicle to, from the petrol vehicle to electrical vehicle? There must be some reason why. Okay, the reason is about the efficiency. Okay, I will this next slide. Okay, if you look in this diagram, the conversion of energy from petrol or gas into kinetic energy is about 30%. And then certain part of the study, they will find that your conversion of is about 70 to 21%, which is quite low. And then another 80% and another 70% to 80% will go to waste in terms of heat, friction, and mostly you can find in the CO2 emission. So this CO2 emission is not good for our environment. So most of the country, if you look in the Europe or European country, they are now moving toward less CO2 emission. So we know that petrol car is low efficient. Okay, the conversion is about 20%, 70 to 21. Okay, now we look back about electrical vehicle. Okay, electrical vehicle is powered by electricity. So we will take a look at the upper stream, which is on the generation. How much energy is converted into electricity, which is from raw energy such as coal, gas into electricity. Okay, for the gas power station, the efficiency to convert the gas from electricity is about 61%. Okay, high efficient. This is combined high. I don't remember this one. Combined cycle power plant, which is about 80 to 90%, which is also quite good. Mean that you will get more electricity from this one. More electricity. And then for the coal power station, on average, it's about 50% the conversion of into electricity. So we will see that this power plant emits less CO2 compared to the conventional or petrol car. Plus, the electricity is not only come from the coal or gas or another fuel. Okay, it is also the electricity also. The generation is also supported by wind, which is zero CO2 emission, and of course it's free. Even though the efficiency is not high, but it is best. Is the attribute is the best attribute is at here. okay, for the wind, which is energy free and less CO2. And then we take a look at the solar. Same. Electricity, I mean, the power station also come from the solar. It has low efficiency, but again, it has free energy and zero CO2 emission. Okay, after you combine all the power system, which is fossil fuel, wind, solar panel, you get a high efficient of conversion of raw energy to electricity, and then there will be less CO2 emission. Okay. The electrical itself have a high efficient. That means to convert electricity energy into kinetic energy is around 80 to 90. So in total, electrical vehicle is the conversion is about 59 to 62, which is better than the petrol, which is 17 to 21%. Okay, so that's why this smart grids, one of the factor in the smart grid is electrical vehicle. Okay, because they are all part of the country are targeting this one. Some country, they are trying to have zero emission, which is quite ambitious for them. Okay, zero CO2 emission, which is quite ambitious. So they try to have less CO2 emission. Okay, when you have this both, okay, as I said before, TMB wants us to change our behavior of using the load, which is fan, aircon, computer. Okay, because they want to invest into another part of, so that's why they want us to change the usage of, change certain part which is applicable, so that they can buy a better equipment. Okay, if you look in UK, okay, in order for them to ask customer to change their behavior of using from for the peak hours to non-peak hours, they provide this economy 7 and economy 10 of tariff. Okay, they are providing this type of tariff. Okay, that means, let's say they have this kind of certain duration. Okay, these are the 7 hours. This is 7 hours. Let's say this is 3 hours for the 10 hours. Okay, if you are using your electricity between this time, your tariff is cheaper. So this attracts some people to use their load at this point. Okay, this would attract some people to use their equipment at this time, because this is much cheaper. For example, let us say if you use at this point, okay, your tariff will be around 50 cent per kilowatt hours. Okay, but if you use at this time, your tariff will be around 10 cents per kWh. Okay, so this would customer to change their usage of behavior during non-peak hours. Okay. In Malaysia we doesn't have. I mean, now Malaysia doesn't have this kind of tariff. Malaysia does give fixed tariff only. It doesn't care whether you use at night or day. The tariff is the same. But for certain country, which is in Europe, they are focused on this one, which is demand side management. Sorry, demand side management. So they want to control the load. I mean, they want to control your usage. So they provide this kind of tariff so that you will change your behavior. Okay. When generator when the load is from this big into this smaller, okay, this is from the part of utility, okay, this is part for utility, which is this is larger, this is smaller, okay. So utility itself can choose which power plant I want to buy electricity. So it has two purpose. Okay, first it can invest in small capital equipment, and then they can buy less cheaper electricity. Because if you look certain power plant, let's say in Selangor or in Negeri Sembilan or in Penang, okay, they have different price. So utility can choose the minimum the cheaper cost to operate okay, and to run in the grid. Okay. Before this, the load is larger, right? So that means utility must buy from this one, buy from this power station, and buy from all power station because the load is larger. Okay, but after control the load, okay, the load becomes smaller, which is manageable. The TMB can only buy from a power station only. Okay, that means they are in control. Okay, so they will only buy at this 30 cent power station only. Okay, there are a lot of questions. Why why generator and why utility need to know generator and load at the same time? Okay, this is because of frequency. All of this is main part. Come into together. If you look in the bigger picture, all of this will come into together. Okay, there are many reasons why utility need to know all type of load, all type of generator. They must be in control because they want to control. They want to make sure that the frequency is stable. Okay, the frequency in order 50 hertz. Okay, 50 hertz. The power of the generation must be the same, almost the same as the load. Okay, must be the same. Okay, must be almost the same as the load. If not, the generator will go unsynchronized and it will trigger blackout. As we see in the previous 1994 and 1992, in the previous national blackout, okay, the load is larger, but the generation is small, so the generation cannot supply the load. So this will cause the generation will go out of synchronized, what will cause national blackout. As we look in previous years, in previous 20 years or 10 years, which is cause national blackout. Okay. Now we will take a look at the solar panel and wind farm, wind energy. Okay. Okay, as we know, wind and solar, which renewable, zero fuel cost, doesn't pollute CO2. And Malaysia has a target, okay? Malaysia has a target, which is their target to have 20% renewable energy in 2035, and this is quite challenging. In 2050, they want 50%. Okay. I mean, this is quite challenging to have 50%. I mean, most of our load is powered by renewable energy. It's quite challenging to have 50% of renewable energy, because we know solar energy. Okay, solar energy comes into handy during the day only. Okay, solar energy comes in power during the day. At night there is no solar. So this target is quite challengeable for the utility to achieve. Okay. Okay, these are the certain reason why we need these are the reason why we need renewable energy. Okay, the coal reserve itself is depletion, and then we know because of CO2, the sea level is become high, and the gas reserve also become lesser. Okay, the oil supply itself also, we know, again become lesser. These are become some trigger point for our Malaysian, in particular for TNB, to change their form of generation to renewable energy. Okay, now we take a look at different part of the world. See, in this figure, you can see that some countries have already changed. So if you say some in Uruguay, Uruguay, they have almost 100% renewable energy. For Scotland, they are building largest wind farm because they have a lot of wind. And Sweden, targeting a fossil fuel free. I mean there will be less CO2. Okay, and then for German also, for the first half, this is quite challenging. It's quite difficult to achieve, but German able to do it. The first half on their 2018, all of the customer is their electricity is come from renewable energy, so it's quite good. So storage and generator. So we take a look at storage and generator. So there are a lot of incentive for the government, so that we as a customer at home install solar panel. So government have this new scheme, which is net energy metering, which they will install solar panel at your home. Okay, and then you will sell the energy. It's either you want to sell or not, but you can sell your energy to NB, and then the energy will cancel on the basis of 1-to-1 on your bill. Okay, let's say for example you are generating, your usage at home is about 250. Okay, your solar generate 200. Okay, so they will minus the 150. So the only thing that you need to pay to TNB is 50 only. Okay, so these are the best scheme at the moment you can apply. And from this, they are a good point. It able to reduce the demand on the grid, able to reduce the stress on the grid. I mean, on the transmission. And then this is one of the best attributes. Let's say your home have a solar. Okay, and then there's a blackout. You still have electricity at your home because you are using solar panel. Okay, so these are the best attributes for installing solar at your home. So there are many schemes. Provided by the government through this SEDA agency, Sustainable Energy Development from the government. Okay, there are certain type of scheme which is Salico, net emitting. This is for not for us. This is for the industry, and feed-in tariff. Okay, so it is better now for us to install solar panel. Okay. So there are many incentive for the government. So these are the P2P scheme, which is they know who are the seller, then they know who are the buyer, and then we can directly sell the energy to the buyer. Okay, the concept of P2P. They know who is the seller, and they know who is the buyer, and then they can directly sell electricity to this buyer. Okay, these are the scheme for the P2P project in Malaysia. Okay, this is okay. Another one is about the disturbance. Okay, sorry, this is for the large utility battery. Okay, in US they have designed this a larger quad battery, so their investment is quite big. So I don't know whether Malaysia will invest in this or not, because the investment is quite big, which is almost 5 billion. So to store energy is quite expensive actually, to store energy. So that's why if you look in the previous slide, the TNB want to know your load, in order to make sure that the load is same as generation. Because to buy storage is quite expensive. To buy storage is quite expensive for them. Okay, these are another component in smart grids, which is in smart grid. They want to know the power quality. They want to know the quality of electrical. Okay, electric. Okay, they want to know the quality of the electric, whether it is best or not. The best electricity is the pure sinusoidal. You have a smooth sinusoidal. Okay, but it is difficult to achieve this one. Sometimes you see this one. Okay, this is the best. This is ideal lah. This is ideal. Okay, now we take a look at certain scenario for the microgrid. I will provide you two scenarios. First one is network configuration, or we can call it, or another term we can call it N-1 or N-2 security. Another scenario is about microgrid. Okay, let's say, we will look at the first scenario. Okay, you have this power station. This power station is supplied substation A, substation B, substation C. Okay, the subsequent substation will will supply their own load, okay, based on their area. Okay, so this is online. That means this is working. This is working, and this is offline. The black one is in offline. Okay, it is there, but it's not turned on. Okay, so for example, when there's a fault here, there's a fault at this transmission line. Okay, so this transmission line need to be open. So when this is open, this substation B will not receive any supply. This load also will not achieve only, will not also achieve supply. Okay, so by allowing network configuration, they turn on this conductor, so this load will have supply. Okay, so this investment is quite a lot actually, because they want to have interconnection between every substation is quite expensive. Okay, so again, this is as a future smart grid. These are the future what we want. These are the future attributes of the future smart grid. We don't want any, customer doesn't want any interruption at all. But at least if you cannot, if the MB cannot neglect that, at least provide us less time of interruption. Okay, less time of interruption. Okay, at least provide us less time of interruption. The best no interruption is quite difficult for them, because we know there will be some lightning, be some human error. There will be some certain disturbance in the network. So at best they can do is have less time of interruption. So by allowing network configuration, this customer B will achieve, will get their supply back after probably around 5 seconds or 10 seconds, depends on the response of the network. Okay, scenario B is about the microgrid. Okay, this is also in the future. Okay, these are the power station. If you look in the part of load B, they have this solar farm or wind farm, okay, which is supplied to load B and also can supply to the substation B. And then you can see there is dual way, two ways of electricity. Okay, this load, this supply can supply to this part, and this load also can supply to this part and to this one. Okay. Okay, during the fault, okay, that's again the same situation. When there's a fault, this part needs to be open. Okay, need to be open, but because of this one, okay, the load bill is still still maintain receiving supply, because this is all this support by microgrid. Okay. I think that's all for the smart grid. Actually, there are lots of components, there are lots of attributes, but to share more, there will be a lot more technical parts. It requires some extensive knowledge for that. So I try my best to make this slide less technical. Okay, now we go to the second part of the presentation, which is how do we want to become an electrical engineer. Okay, it's a good. Okay, after SPM, okay, we don't look at this one. Okay, this one is if you want to become professional engineer, it's different. We don't. This one is we just neglect. Okay, Okay, how you want to become a electrical engineer? Okay, after SPM, you can either continue by matriculation, diploma, or getting a certificate. Okay. This one, matriculation, is probably they are 1 to 2 years. Okay, and then after that you need to continue degree for 4 years. Okay, for diploma, if you look at this is path A. If you follow the path B, you need to finish the diploma for 3 years and then apply degree for 3 years. So if you look here, this is 5 to 6. This is 6 years. Okay, for certain person, maybe they are taking a longer route. They need to take certificate first, probably 1 to 2 years, and then diploma for 2 years, and then finish degree for 3 years. So this one will accumulate about 7 years. Okay, it depends on it depends on the result of the SPM. If your result SPM is good, you can follow path of A. If in the middle or something, if you want to play safe, not play safe. If you want to have because if you want to have to take a lot of degree, you can take diploma and then continue to degree certificate. Okay, but make sure when you continue your degree, if you want to become electrical engineer, make sure that that program is accredited by ESE. Okay, this is something that most of the person doesn't take into account. Okay, they must be accredited by ESE. Okay, this is for in Malaysia. Okay, in Malaysia. Okay, and then of course you need to pass all the course. And then lastly, don't forget to register as graduate engineer with BEM. Okay, because there's a clause in there's a rule. There's a law in that, which is if engineer want to practice teaching or do anything with engineering, you need to register as graduate engineer with BEM. Okay, so this is mandatory. Okay, so UMP offers these two programs. We have one is electronic, okay, and then this one is in electrical. Okay, both of our program is accredited by ESE. Okay, that is something that you need to take into account. Okay, before you further study, make sure that program is accredited by ESE because you want to become engineer. Okay. Okay, if you want to take another route, it's different. Okay, it is also you can become engineer. Let's say you take an engineering technology program. Okay, if you look at the route here, after you finish degree, okay, here you will become engineer technologist and then you can become graduate engineer. Okay. If you are applying for engineering technology degree, look here, I calculate. That program must be accredited by TAC. Okay, must be accredited by ETAC, and then of course, must pass all the exam or the test. And then you need to register as graduate engineer technologist with BM. And then if you want to change from engineering technology here to graduate engineer, you need to take certain courses. Okay. I think that's all from me. Oh, it's about my presentation is about 1 hour and a half. It's quite long. I just okay. Okay. Hazlina? Hello?
Hello. Thank you. Thank you very much Dr. Ikhwan. So kalau
Okay.
tengok dekat sini, kita ada macam beberapa soalan. Cumanya sebelum kita masuk kepada sesi soal jawab tu, kita take a break sekejap boleh? Kita ada tayangan video.
Boleh.
Nanti kan dalam lepas tu kita akan pick up soalan dan try to address the questions. Boleh ya?
Question, okay.
Okay, terima kasih.
Lebih dahulu bagi pihak pengurusan dan seluruh warga Universiti Malaysia Pahang, saya ingin mengucapkan selamat datang dan mengalu-alukan kehadiran hadirin sekalian, khususnya kepada tamu kehormat, iaitu Yang Berhormat Dr. Mazli Malik, Menteri Pendidikan Malaysia ke UMP Kampus Gampang kepada acara. Secara khususnya, kami di UMP amatlah berbesar hati dengan kehadiran YP pada hari ini. Kerana ini merupakan kunjungan rasmi solo beliau ke sini sejak menyandang amanah sebagai Menteri Pendidikan. Selamat datang.
We make these memories for ourselves, where our eyes are never closing, our hearts are never broken.
Menunjukkan pendidikan STEM perlu menggalakkan murid agar diberi peluang untuk melakukan pembelajaran berasaskan individu. Kaedah pembelajaran berasaskan individu melibatkan penerokaan alam melalui proses menyoal, menyiasat dan menyelesaikan masalah.
Loving can heal, loving can mend your soul, and it's the only thing that I know. I swear it will get easier. Remember that with every pace, yeah. And it's the only thing we take with us when we die. Keep this love in its photograph. We make these memories.
Kita berharap supaya program hari ini bukanlah program yang pertama terakhir, tetapi program yang pertama di dalam sejuta program-program lain yang akan kita usahakan. Akhirnya dalam kesempatan ini, saya ingin mengucapkan terima kasih kepada semua yang terlibat, terutamanya kepada PTRB kepada USP, kepada JCS Negeri Pahang, kepada Pusat STEM Negara, dan kepada guru-guru dan juga guru besar sekalian. Maka dengan kalimah yang mulia, Bismillahirrahmanirrahim, saya dengan ini merasmikan Kolej Pendidikan STEM Kebangsaan 2019. Sekian, wassalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh.
I will remember how you kissed me under the lamppost back on 6th Street, hearing you whisper through the phone, wait for me to come home.
Okay.
Okay.
Ikhwan ready
Okay, ready.
Basically kita ada lebih kurang 15 soalan yang mana yang telah
Okay.
ditanyakan oleh peserta tadi.
Okay.
Soalan yang 1 dan 3 tu Dr. Ikhwan basically dah jawab dalam
Okay.
dalam presentation tadi. Okay, saya mulakan saya sambung dengan soalan nombor 4. Ada peserta ni tanyalah, adakah terdapat perbezaan antara tenaga yang dihasilkan oleh empangan daripada empangan dengan tenaga yang kita dapat daripada wind turbine? Ada perbezaan tak in terms of tenaga tu?
Kalau tengok daripada customer tak tahu pun nak tenaga tu daripada mana. Kita tak tahu pun, macam kita sekarang guna pun kita tak tahu pun daripada mana. Cuma perbezaan dia kalau dari sudut macam contoh daripada TMB, dia main peranan lah macam saya cerita tadi. Kalau macam wind, selalu kita boleh on dia 24 jam. Sebab wind, yelah kalau macam kat luar negara, memang angin dia kuat 24 jam. Okay, jadi kita boleh buka je. Okay. Kalau macam hydro, tengok juga macam negara China, kita tahu kan China ada apa? Biggest dam kat in the world kan. Memang dia boleh buka 24 jam. Tapi dua-dua tu tak ada beza lah sebenarnya. Dua-dua tu renewable energy.
Okay. Tadi pun Dr. Ikhwan ada mention yang menarik juga tu, nak menyimpan tenaga rupanya mahal sebab tu TNB
mahal.
Dia nak estimate tu elok-elok supaya dia generate terus deliver. Betul?
Sebab tu sebab saya tengok tadi yang US tu, itu yang terbaru tu. Yang tu dalam awal tahun ni juga. Dia invest dekat 5 bilion USD. Tak tahulah TNB ada duit. Tapi kalau semata-mata nak invest 5 bilion USD, taklah kot.
Tinggi ya. Okay.
Tinggi
right,
betul.
Kita pergi kepada soalan next one. Okay, yang ini ditanya tentang how many types of cables did they use for the tower for transmission? Maybe macam jenis-jenis kabel.
Dia berbeza lah. Kalau macam untuk 132 kV dia lain. Dia ada nama dia tapi saya tak ingat. Yang saya ingat nama Wolf je, dan nama Wolf, Skunk, dia ada nama-nama dia lah. Dia kebanyakannya nama tu dia ambil nama binatang. Saya tak tahu kenapa lah. Okay. Tapi macam saya cakap tadi, untuk 132 kV dia pakai kabel lain. 275 kV pakai konduktor lain. 500 pun dia pakai konduktor lain. Dia tak pakai sama lah. Sebab dia punya kapasiti tu berbeza. Kapasiti dia berbeza. Macam 500 kapasiti besar. Jadi dia boleh pakai kabel saiz lain. Dia tak boleh pakai kabel saiz yang kecil macam 132 kV tadi.
Boleh terbakar kan? Boleh rosak lah. Betul.
Tak cukup.
Okay, the next one dia tanya, adakah sistem solar cukup untuk memenuhi sumber keperluan tenaga bumi?
Itu nak tengok. Kalau cukup solar tu cukup, cuma kita panel tu tak ada. Masalahnya kalau semua orang boleh pasang, boleh sebenarnya. Tapi kos pasang tu mahal. Kita boleh tengoklah dekat laman web Seda ke dekat Taman TMB, dia ada tunjuklah kos nak pasang 4 kilowatt pun. 4 kilowatt dalam average 4 kilowatt hours dalam 20k tau. itu kecil tu. Kecil. 20k lah, 20,000. Memang kalau boleh memang yelah, tapi macam saya cakap sebelum ni, bukan solar tak boleh guna. Cuma solar ni dia available siang je. Malam tu kita nak pakai bateri, yelah bateri pun dia ada yelah ini dah go technical. Bateri pun dia ada dia punya cycle dia. Kan? Makin lama bateri berapa lama dia boleh storage. Okay, jadi dia banyaklah faktor nak pilih tu. Tapi kalau kalau semua ada duit, semua boleh pasang, boleh lah sebenarnya. Cuma duit lah masalah dia.
Kena upfront dia, permulaan dia mahal, lama-lama
Malah.
Okay. Alright, next question, soalan nombor 7 ni. Dia tanya berapa lamakah sumber tenaga daripada wind turbine ni ada di bumi? Saya rasa dia punya maksud ni kot, I mean kalau macam Dr. Ikhwan bagi tahu tadi, selagi ada angin adalah tenaga kan.
Ada
Mungkin
dia.
kalau saya ubah suai sikit lah soalan yang peserta ni tanya ni, maybe berapa lama boleh disimpan kot?
Simpan, macam saya cakap tadi, wind tak boleh simpan, energi tak boleh simpan. Sebab kita tak ada storage tu. Storage tu mahal. Lagi satu, kalau kat Malaysia pun, tadi rasa ada tanya kot, kat Malaysia ada ke tak? Malaysia ada tapi macam tak berapa nak jalan sebab angin ni tak cukup kuat nak pusing turbine tu.
Betul. Kalau dekat Scotland dulu angin style macam boleh terbang kan. Kira orang lalu
boleh terbang. Boleh terbang. Betul.
Level.
Dia tak, sebab dia punya bilah tu memang betul-betul berat tau. Bilah dia macam satu bilah dia macam berat berapa biji kereta.
Nampak daripada jauh kecil kan, tapi dia besar sebenarnya.
Itulah, bilah tu berat, jadi kalau nak pusing, angin Malaysia memang tak pusing lah. Okey, jadi itulah kelemahan, itulah satu sumber yang kita tak boleh manfaat dekat Malaysia ni. Kalau Malaysia boleh manfaat wind ni memang best lah, sebab dia available 24 jam macam dekat Scotland kan, kan dekat UK.
Okay. Alright, okay, next question. Soalan nombor 8 ni, dia tanya berapa kerap maintenance di distribution tower dilakukan? Saya tak pasti dia maksudkan maintenance apa, maybe secara umum lah.
Okay, sekejap Maintenance ada dua, dia ada preventif dengan korektif. Okay, kalau preventif memang kita buat tiap tahun. Bukan akulah, aku keluar TMB. TMB dia akan buat preventif tiap tahun. Okay, preventif tiap tahun. Okay, dia akan check setiap tu, tiap tahun dia akan check. Bila dia nampak rosak, dia masuk preventif tu, sebelum rosak dia dah check lah kan. Nampak tak? Sebelum rosak dia dah betul kan. Tapi kalau macam korektif tu dah selepas rosak tu benda lain lah. Mungkin sebab fault. Kalau sebab fault macam tiba-tiba ada kilat ataupun kayu tu patah, menara tu patah kan, itu tak boleh buat apalah. Tapi kalau tanya preventive maintenance memang tiap tahun.
Okay, soalan nombor 9, ada dia tanya dekat sini, kenapa first transformer perlu step up? Yang ni pun ini jawapannya teknikal. Kalau nak dia kena tulis equation, penat sikit lah. Tapi jawapan simple dia, sebab kita tak nak loss. The loss dekat core losses. Tu dah masuk teknikal dah tu. Masih dia loss tu nak mengingatkan loss, kena step up dulu lah kan. Lepas tu baru kita buat distribution. Okay. Good. Okay, next one, soalan nombor 10 ni. Okay, yang ni dia tanya ni, selepas habis diploma dan degree, kerja apa yang boleh kita pilih? Mungkin ini kot, nanti Dr. Ikhwan boleh menjelaskan. Ada share tadi. Ataupun maybe boleh bagi ulasan kot, macam selalunya pelajar yang dah habis diploma ni, diorang mesti dilema, nak pergi kerja ke nak sambung degree? So pendapat Dr. Ikhwan, which one is better?
Macam negara sekarang memerlukan, kalau ikutkan negara sekarang memerlukan engineer yang banyak lah. Kalau boleh sambung lah kan. Agak rugilah kalau kita tak sambung, tak tambah ilmu. Okay, itu kalau boleh sambung lah, habis master PhD pun kalau boleh sambung lah, sebab itu ilmu kan. Tapi kalau boleh habiskanlah sampai degree. Sebab lebih banyak kita tahu. Sebab kalau diploma ni kita tengok kerja dia macam technician, dia lebih kepada macam hands on. Dia tak banyak tahu, lebih pada macam teori. Macam tadi tu masa saya cerita banyak tadi tu kan. Kenapa kita nak tahu load, kenapa kita nak tahu supply. Kalau tanya student-student yang macam diploma, ada yang boleh jawab, dia tak boleh. Tapi kebanyakan kalau bertanya degree, kebanyakannya boleh jawab. Dia tahu kenapa jadi ni, kenapa nak, dia boleh tahu sebab apa. Sebab tu kalau boleh, kalau boleh sampai PhD lah. Tapi kalau tak boleh, sampai nak jadi engineer sampai degree.
Tadi masa dalam slide Dr. Ikhwan, dekat belah kanan tu Dr. Ikhwan dia tunjuk route untuk nak become professional engineer ataupun insinyur. So untuk nak ke route tu minimum degree perlu ada degree baru boleh ambil
degree. Perlu degree. Perlu ada degree.
Okay. Alright, the next one, soalan nombor 11. Ada yang tunjuk slide tadi ke? Okay.
Tak ada.
Okay. Okay, alright. So the next one, soalan nombor 11 kat sini, dia tanya apakah pengalaman yang paling menggerikan dengan sektor voltan ini?
Macam ni saya tak adalah, sebab Kalau saya tak hati-hati macam saya kerja dekat masa TMB dulu, memang kerja dekat yang menara tinggi tadi tu. Selalunya dia punya nak kita kata nak jatuh tu adalah. Nak jatuh, nak kena dengan elektrik tu pun boleh. Macam dekat substation, kalau kita tengok dekat substation yang selalu bahayanya dekat kalau untuk distribution lah. Dia bahaya dekat dia punya circuit breaker. Sebab circuit breaker kan kita nak putuskan litar kan. Kalau ikut yang distribution punya, bukan yang transmission Distribution dia punya apa? Circuit breaker dia manual kena tarik. Tarik manual, maksudnya benda tu kalau tarik, maksudnya kalau kita putuskan sesuatu yang tengah tinggi, dia boleh meletup tau. Sebab tu agak bahaya. Tapi tak apa, tapi selalunya benda ni selamat kalau kita ikut prosedur dia. Selalunya kalau kita skip prosedur tu yang macam bahaya tu, macam contoh tadi saya kalau macam saya tadi bekerja dekat bahagian tinggi kan, dekat bahagian menara tadi tu, kan kita panjat kan. Kita kena pakai apa ni tau, safety ada tali lah. Aku tak ingat apa nama dia. Ni kena pakai setiap kali harness tu. Setiap kali kita panjat kena cangkuk. Dia ada 2 cangkuk tau. Cangkuk satu, cangkuk bawah lepas. Cangkuk satu lagi, cangkuk bawah lepas. Dia mesti sentiasa cangkuk. Kadang-kadang bila orang dah macam, yelah, ada je yang macam dia bila skip prosedur tu yang jadi bahaya tu. Tu yang boleh jatuh. Okay.
Yang tu satu lagi flash Saya kadang-kadang tengok kalau kat high voltage ni flash tu pun sekali
tu arcing. Itu arcing nama dia. Tu arcing. Itu arcing kalau kita buka bukan dalam circuit breaker. Kalau circuit breaker dia inilah teknikal ni. Dalam circuit breaker dia ada satu medium yang extinguish arcing tu. Tapi kalau kita buka selain daripada circuit breaker, macam contoh yang kita nampak arcing tu, yang kita dapat kat mana-mana video kan, itu dia buka isolator.
Okay, isolator.
Dia buka isolator. Isolator tu tak ada medium nak diminish arcing tu. Itu yang kita nampak arcing tu. Itulah dia teknikal.
Okay, next one. Okay, soalan nombor 12 ni dah jawab tadi ni. Tapi okay, dia tanya kat sini kenapa negara kita tak buat dengan kincir angin? Tadi tu Ikhwan beritahu tak cukup angin
kita tak cukup.
Cuma saya lanjut sikit soalan ni. Kalau dekat UK dulu kan, dia ada 2. Satu kincir angin yang atas darat, satu lagi kincir angin yang dekat laut. Banyak beza tak antara dua ni?
Dia bila dekat laut tu dia boleh letak mana-mana lah, senang.
I see.
Dia nak land requirement tu senang. Lagi satu dia nak susun angin tu sebab ada jarak dia kan. Dia boleh susun dengan baik lah. Kalau macam kat tu kita sebab bukit tu berbukit-bukit. Jadi angin tu susah nak kontrol sikit.
Okay. So faktor ni faktor kita nak buat placement dia lah satu.
Placement. Tapi banyak juga sebab lagi. Kalau dia buat study juga angin mana yang kuat. Yalah. Tapi seloknya laut dah, dia tak kacau orang.
Tak kacau orang. Cuma masa kita time dekat UK dulu tahun 2013 tu, saya ingat ada Donald Trump dia ada buat komplain sikit kalau letak dekat laut tu golf course tu nampak pemandangan, nampak wind turbine tu, so dia kata mengganggu keharmonian dia nak main golf. Tapi ini je lah faktor.
Itu pandangan dia. Itu pandangan dia. Tapi ada orang suka je ambil gambar belakang wind turbine.
Background itu kan. Betul. Apa nama tu? Okay, kita move to the next question. Okay, soalan ni soalan umum ni. How to save electricity? Untuk switch kita nak guna.
Waktu switch tu lah. Satu kita guna ni pun dia ada macam kalau tengok sekarang government dah ke arah barang kecekapan tenaga. Kalau kita tengok macam peti ais, aircon, TV, kat situ kan ada macam stiker, ada berapa star kan. Nampak tak? Kalau kita beli kan, kat situ dia ada situ efficiency star tu. Kalau nak save energy, beli yang 5 star. Tapi mahal sikit lah. Itulah. Yelah, kalau cara nak pada senang ni tak guna lah, senang cerita. Tapi itu macam pelik pula. Takkan aku dah beli kipas tak guna.
Betul. Okay. So ni akhirnya barang-barang elektrik tu sendiri kalau dia dah efficient, jadi requirement dia kepada energy pun dah kurang. So kita dapat jimatkan juga lah kan electricity.
Betul.
Okay.
Lagi satu ni, kita punya penggunaan. Contoh macam Kalau kita macam kita baju contoh, basuh baju yang sekali banyak, jangan basuh sikit-sikit. Itu pun salah satu cara nak jimat elektrik.
Sekali pakai lah kan, sekali pakai. Tadi
sekali
ada
pakai.
Dr. Ikhwan bagi tahu aircon kalau kita ada 5 aircon pun, kalau kita buka satu-satu single phase pun dah cukup. Tapi kalau kita ada 3 aircon, 4 aircon, buka serentak terus surge saja dia banyak kan.
Dia banyak. Jadi dia perlukan, rumah tu perlukan 3 phase. Okay.
Alright, okay. Ada satu soalan ni last soalan last. Dia tanya ni, how to be excellent and talented student like you, Dr. Okay, kepada penonton sekalian okay. Dr. Ikhwan ni dia interesting juga ni. Dia buat degree, kemudian degree dia dapat Pusat cemerlang, sambung di buat PhD di Edinburgh University terus tanpa buat masters direct kepada PhD terus. So boleh share tips saya seramai penonton kita ni
tak ada saya kata tanya biasa je. kena study smart lah, senang cerita, kena study smart lah, kena tahu dia yang penting masih yang saya nampak lah, kalau tengok bila lecture mengajar tu memang kena fokus. Lepas tu kalau boleh lah sebelum lecture mengajar tu study sikit jangan sampai lecture ajar tu. Itulah dia punya tips dia. Kalau macam kita masuk terus kosong agak susah lah sebenarnya. Bila lecture mengajar tu kita dah tahu sikit kan, bila kita boleh tahu dah apa yang kita tak tahu, apa yang kita tahu. Nanti bila lecture tu ajar kita boleh terus tanya. Macam itulah yang saya nampak kebanyakannya student kita kurang kat situ. Itu ya, kena study smart lah sebenarnya.
Tadi yang Dr. Ikhwan cakap tu menarik. Bila kita tak tahu tu kita terus tanya kan. So during lecture tu kalau dah prepare awal, dah tahu apa yang you tak tahu, bolehlah tanya. Kalau waktu tu baru nak tahu, lambat lah kan.
Itulah memanglah sebab dia macam kalau boleh kena study sikit dulu.
Okay. Alright. So thank you very much Dr. Ikhwan. Saya rasa sesi ni yang paling penuh ni masa ni. Cukup 2 jam ni, dan alhamdulillah kita dapat address semua soalan yang telah ditanyakan.
Nak jadi maintenance kau.
Okay.
Tak jadi maintenance grid. Kita nak jadi maintenance grid untuk apa? Kalau nak buat maintenance, contoh ialah sebenarnya soalan ni macam umum sangat sebenarnya. Yalah, sebab engineer selalu dia tak buat kerja tu. Engineer dia selalu dia schedule, dia tengok bila dia tak adalah engineer tu as on. Tapi selalu yang betul-betul buat ni, tapi dengan guidance engineer lah, technician. Tapi engineer perlu tahu juga apa yang dia buat. Dia tak boleh macam kau buat lah kan, tak boleh macam tu. Engineer kena tahu yang dia buat tu apa, betul ke tak betul. Jadi kalau seboleh-bolehnya cukup degree tu boleh untuk buat maintenance.
Okey. Sijil yang Muhammad Hafizul tadi tanya ni, sijil yang dimasukkan tu adakah sijil yang SKM tu SKM 1?
SKM itu lain, itu dah lain dah. Itu dah macam itu dah macam kemahiran. Kemahiran okey. Okey, alright. Dia banyak lagi sebenarnya. Kalau kita nak jadi competent engineer, dia ada sijil lain lagi. Dia lagi tinggi daripada IR ni.
Okey.
Competent engineer nama dia.
Competent engineer. Okey.
Itu nanti
yang bagi award tu siapa tu? BEM yang bagi award competent engineer tu?
Suruhanjaya Tenaga. Okey, kalau tengok dia ada beza Kalau kita punya IR ni, BM ni, kita boleh sahkan drawing je. Okey, sahkan drawing, check drawing tu betul tak betul. Tapi siapa yang boleh hands on benda tu? Hands on tu sama ada competent engineer ataupun juruteraan perkhidmatan je boleh buat. Dia boleh touch, dia boleh buat semua tu. Ada beza sikit.
Okay. So kalau macam untuk yang siapa nak apply competent engineer ni, dia mesti professional engineer ke ataupun
dia mesti professional engineer. Lepas tu dia mesti pengalaman dia dah 10 tahun. Maksudnya dia dah biasa dengan equipment tu. Dia dah biasa.
Okay. Alright.
Dia banyaklah.
Thank you for sharing this. Kepada sesiapa yang masuk lewat sikit apa semua ni, kita ada rekod sesi ni dan boleh datang ke YouTube channel dekat UMP STEM Lab, boleh tengok baliklah daripada awal. Kalau tengok tadi ni Dr. Ikhwan bawa daripada asas sampailah ke, bagi saya agak detail jugalah tu, pada macam pelajar-pelajar diploma boleh have an overview and what to expect daripada sini. Okey, Dr. Ikhwan lah soalan ni baru masuk. Nak ambil tak satu soalan ni? Dia tanya
Boleh lah, boleh lah.
sijil komputer macam mana tu? A0, A1, A4?
Oh, itu A4 A1 tu untuk ni, A4 itu untuk judgement. Judgement dia punya level dia level diploma. A1 itu betul diploma ke bawah. Kalau kita ada degree, kita akan ambil computer engineer ataupun juruteraan perkhidmatan. Maksudnya kita lagi tinggi daripada sijil semua tadi tu. Tadi tu yang kita sedia nanti cakap tadi A0 sampai A4 tadi tu, computer engineer dengan juruteraan lagi tinggi daripada semua tu.
Okey.
Dia punya
So
level.
tadi yang macam bagi kita tadi dah buat diploma tu, kalau ada sambung sikit lagi nak lengkapkan degree, boleh panjat lagi tinggi lah, insyaAllah.
Panjat tinggi. Yalah, kalau boleh kita cuba achieve yang paling tinggi lah.
Betul.
Okay.
Alright. Okay. So thank you very much again Technologies Engineer Dr. Muhammad Ikhwan Muhammad RIdzuan. Saya juga nak ambil kesempatan ni, saya nak ucapkan terima kasih kepada Ustaz Hasnur selaku technical assistant kita pada petang ni. Terima kasih sekali lagi semua. InsyaAllah kita akan announce time soon untuk program-program kita yang akan datang. Okay, terima kasih. Jumpa lagi insyaAllah. Assalamualaikum.